Deep Neural Network, DNN, Architecture for ISO 21001 Implementation in the Education Sector. Model by Pradeep K. Suri. All types of inputs. 9 hidden layers representing processing stages. All outputs aligned with ISO 21001 functional outcomes. Designed for AI-driven decision-making in educational institutions. DNN structure for ISO 21001, Education Sector. Input layer, data sources. Inputs align with ISO 21001's focus areas such as learner needs, curriculum, performance, and engagement. Category input nodes. Learner profile: age, gender, socioeconomic status, learning style, special needs. Academic records: attendance percent, assignment scores, exam scores, class participation. Feedback: student feedback, parent feedback, teacher feedback. Teaching inputs: curriculum quality, teaching hours, teacher competency score. Institutional context: class size, infrastructure quality, digital access, peer interaction. Stakeholder expectations: parent expectations, regulatory requirements, industry linkage. Hidden layers: 9 layers, core ISO 21001 processing. Hidden layer: functional focus. Hidden layer 1: pre-processing and normalization, clean and normalize data. Hidden layer 2: context analysis, learner needs vs program objectives. Hidden layer 3: teaching strategy matching, match pedagogy to learner type. Hidden layer 4: risk identification, dropout prediction, disengagement risk. Hidden layer 5: learning pattern recognition, AI find study/behavioral patterns. Hidden layer 6: curriculum effectiveness evaluation, curriculum vs outcomes. Hidden layer 7: teacher performance analytics, KPI-based effectiveness scores. Hidden layer 8: stakeholder satisfaction mapping, feedback analysis and trends. Hidden layer 9: outcome alignment with ISO 21001 clauses, education policy validation. Output layer, aligned with ISO 21001 outcomes. Output category: output nodes. Bluebook: student outcomes performance improvement score, engagement index, learning gaps identified. Woman teacher outputs professional development needs, competency gap score, teaching impact score. Bar chart: institutional metrics quality objective achievement percent, process improvement score, ISO 21001 compliance status. Feedback outcomes: stakeholder satisfaction index, feedback response score, parent communication score. Globe showing Europe Africa policy and governance education strategy alignment, risk management alerts, continuous improvement recommendations. Brain AI outputs actionable recommendations, predictive risk alerts, learner-tailored interventions. Final output summary, ready for management dashboards. Learner-centric view, individual growth and gap reports. Teacher improvement plan, with targeted training focus. Institutional audit report, based on ISO 21001 clause mapping. Predictive analytics, risk flags for dropout, disengagement, failure. AI recommendations, adaptive learning strategies and policy alerts. Explanation of the video, ISO 21001, 3D DNN Network, by Pradeep K. Suri. File, 3dflow.mp4. This video visualizes a 3D deep neural network, DNN, inspired by ISO 21001 for the education sector. It features vibrant, rotating layers to illustrate how data flows from inputs to outputs through intelligent hidden layers. Brain 1. Input layer, like sensory organs. These 22 nodes represent real-world educational inputs, just like how our senses gather data for the brain. Category examples of inputs. Student profile: age, gender, socioeconomic status, special needs. Academic metrics: attendance percent, assignment scores, exam scores, class participation. Feedback channels: student feedback, parent feedback, teacher feedback. Institutional context: class size, teaching hours, curriculum quality, infrastructure. Environment: digital access, peer interaction, regulatory requirements. These are equivalent to sensory inputs in the human brain like vision, hearing, and touch. Brain 2. Hidden layers, like brain cortex processing regions. Each of the 10 hidden layers functions as a specialized cognitive filter, mimicking the way the human brain processes information in parallel across different lobes. Hidden layer functions and brain analogies. Hidden layer function brain analogy. Normalize layer standardizes data thalamus, filters and relays sensory signals. Context match layer aligns inputs to real-world context prefrontal cortex, logic and relevance. Strategy match layer compares against teaching strategies frontal lobe, strategic planning. Risk pred layer identifies risk of learning gaps amygdala, threat detection. Pattern recog layer detects learning patterns temporal lobe, pattern recognition. Curriculum eval layer evaluates subject content hippocampus, knowledge association. Teacher eval layer scores teacher effectiveness medial cortex, social judgment. Stakeholder map layer maps roles, parent, teacher, admin, parietal cortex, role-based navigation. ISO clause map layer links actions to ISO 21001 compliance executive brain, regulatory mapping. PTM layer, new, tracks performance metrics cerebellum, continuous monitoring and feedback. These layers simulate parallel and hierarchical processing, just like neural circuits do in human cognition. 3. Output layer, decisions and actions. The output layer generates education quality indicators used by institutions and management. Output node meaning. Performance score overall academic outcome. Engagement index learner participation and interest. Learning gaps deficiencies and areas needing support. Teacher development plan suggestions for staff training. Teaching impact quality of instruction delivery. ISO compliance alignment with ISO 21001 clauses. Feedback score aggregated opinions from stakeholders. Risk alerts early warnings on institutional or student issues. AI suggestions data-driven recommendations, like auto advice engine. Much like how the human brain outputs speech or motion, this AI system outputs actionable education insights. Brain desktop computer human brain vs DNN, summary comparison. Aspect human brain DNN in video. Data input sensory input, eyes, ears, etc. Student/institutional data. Pre-processing thalamus filters signals normalize and context match layers. Decision logic frontal cortex strategy match, risk pred, pattern recog. Regulation mapping brain integrates learned laws ISO clause map plus PTM layer. Feedback loops continuous feedback, e.g. pain, emotion, PTM layer plus risk alerts. Outputs behavior, motion, language performance scores, suggestions, alerts. Video highlights. Rotating 3D view simulates data movement across neural layers. Vibrant node colors distinguish different cognitive areas. Edges represent neural connections, just like axons/synapses in the brain. The addition of PTM layer reflects ISO 21001's emphasis on continuous improvement. To use the video, 3dflow.mp4, effectively in mentorship program, we can break it into a structured format that supports learning, engagement, and real-world application. Below is a complete plan. Mentorship program integration plan, using 3dflow.mp4. Direct hit purpose of the video. The video represents a 3D DNN, deep neural network, flow, ideal for explaining how information moves from inputs rightward arrow hidden layers rightward arrow outputs. Mentor, mentee journey through stages of learning and transformation. Mapping AI decision-making logic to career progression or project flow. Bluebook step-by-step use in mentorship. 1 Orientation session. Play the video at the beginning. Explain, this 3D animation represents how structured learning and guidance help ments move from raw potential, inputs, to outcomes, career growth, project readiness, innovation. 2 Breakdown in modules. Layer in video mentorship mapping. Input layer mentee's background, skills, goals, challenges. Hidden layer 1 to 5 mentorship stages, skill building, domain exposure, ethics, feedback. Output layer result, career clarity, projects completed, certifications. 3 workshop activities. Pause the video layer by layer. Ask mentors, where do you think you currently are in this flow? Discuss, what inputs do you need to improve? Which hidden layer, stage, are you working on now? 4 visual slide deck. Create a PowerPoint presentation using screenshots of each layer from the video. Layer-wise explanation with icons, skills, learning methods, outcomes. Add feedback forms at each stage of the flow. 5 use in review meetings. Show video to review progress. Add overlays, mentor observations, mentee reflections. Compare beginning and end states using animated transitions. Chart increasing enhancements for effective learning. Feature implementation tip. Microphone narration. Add voiceover explaining each flow step. I can help write this. Bar chart graphs. Add overlays showing skill improvement at each stage. Interactivity. Use embedded questions or branching video flows, for LMS use. Brain AI perspective. Compare mentor guidance to hidden layers in AI, like refining weights during learning. File folder deliverables for mentorship program. 1 narrated MP4, with mentor voice guiding through the video. 2 PPT deck, 1 slide per layer with visuals and discussion prompts. 3 workbook, PDF, with checkpoints and reflection forms. 4 poster infographic, DNN flow of mentorship, printable. Direct hit key points of the 3D flow mentorship video, for mentors. Title, 3D flow mentorship model. Purpose, to visually represent how a mentee progresses through the mentorship journey using a deep neural network, DNN, as a metaphor. 1 input layer, starting point. Represents the initial condition of the mentee. Inputs may include prior knowledge, learning goals, skill gaps, mentor role. Assess, listen, and document these attributes carefully before designing the mentorship plan. 2 hidden layers, mentorship stages. Each hidden layer symbolizes a transformation step, similar to how neurons process data in a DNN. Hidden layer 1, foundation. Teach basics, mindset, and principles. Build trust and clarity. Hidden layer 2, domain introduction. Introduce real-world concepts and structured topics. Identify domain fit and interest. Hidden layer 3, application phase. Assign practical tasks. Evaluate how mentors apply learned skills. Hidden layer 4, feedback and correction. Offer feedback loops. Help mentors reflect, revise, and improve. Hidden layer 5, refinement and ownership. Mentors begin to take initiative. Skills mature into confidence and autonomy. Mentor role across layers. Act as a coach, trainer, and guide. Provide checkpoints and motivational nudges. 3 output layer, measurable outcome. Represents certifications achieved. Final projects completed. Confidence and clarity in the mentee's career plan. Mentor role, celebrate success, conduct final review, give recommendations for future growth. 4 mentor reflection, feedback loop. How well did the mentee transform? Was the mentorship timeline realistic? What support or tools were most effective? What should be adjusted for future mentors? Best practices for mentors, from Video Insights. Area guiding thought. Visual journey. Use the 3D flow to explain where mentors are in the journey. Layer-wise goals. Define what success looks like for each stage. Emotional intelligence. Observe mentee motivation dips and address them. Iterative improvement. Be open to changing your approach midway. Would you like a poster PDF, or a mentor handbook based on this video's flow structure? Thanks for watching the video.